For section 3.2b, I want to give you guys a couple hints about figuring out which types of problems correlate with which examples. So there were 3 examples in this section. We had 3.14, which was about the coefficient of variation, or the CV. I want to give you guys a couple hints in this video about how to do this problem using Excel. Okay, then we had 3.16. Okay, this was the empirical rule. Okay, there were 3 problems under here. In part A, we were given 2 values and we wanted to find the percent. Okay, I think part A is quite straightforward. Your answer is either going to be 68%, 95%, or 99.7%, depending on whether you are 1, 2, or 3 standard deviations. Part B, we were given 1 value and asked to find the percent. This, I think, is a little tougher. I want to give you guys some help with these. Then in part C, we were given the percentage and asked to find the values. Well, I have done both my practice and my certify, and I didn't have any examples like 3.16c. Then in 317, this was Chevyshev's. And in the example you were given, we were given 2 values and asked to find the percentage, which I think is straightforward. Now what's tough, and I did not see an example of this, is when you are given a percentage and asked to find the values. Okay, I did not see an example like this in the book. So the things I want to help you with, I want to help you with this case here, which I didn't see an example for. I want to help you with this case here. We have one example, but I think finding those percentages is a little tougher, so I want to help you a little with those. And the third thing I want to help you with is Excel here. And like I said, I did not have any examples of 3.16c. In my first example here, I'm reading and I see this is an empirical rule problem. So this is like 3.16. Okay, I'm given the mean and the standard deviation, but here I'm just given 1 value as opposed to finding the area between 2 and asked to find the percentage. So this is like 3.16b. This is the tougher case. So let's give this one a go. All right, so the first thing we need to do is find our z-score. So to find the z-score, we take the value, which I'll call x, subtract off the mean, and then divide by the standard deviation. So for our case, our value here is 66. I want to subtract off the mean, which is 84. And then I want to divide by the standard deviation, which is 9. So if we were to do that, I get negative 18 divided by 9 is negative 2. Okay, so if I think about that bell curve, so we want to find the probability or the percentage of readers that are greater than. So if my value is negative 2, greater than is going to be all of this area. What makes this a little harder, we know from what's given to us that between negative 2 and positive 2 is 95%. That was one of the ones that was given us, 68, 95, and 99.7. However, that does not account for this little bit here. So here's what I want to do. I need to figure out what this is. Well, if this middle piece here, this black piece is 95%. I need to add on this. So I have 5% left over between these two tails. Well, these are symmetric, so that means that this one's going to be 2.5%, and this one over here is going to be 2.5%. So if I want everything to the right, that's going to be this 95% plus this 2.5%. So I would get 97.5%. Okay, so that was like 316B. Okay, the next one that comes up here, I am asked to find the coefficient of variation, or the CV, given two data sets. This is like 3.14. I need to show you how to do this in Excel. So I'm going to click this copy data button so I don't have to type each number in, and I'm going to paste these data into Excel. Now if you remember here for the CV, we need the standard deviation divided by the mean, and then we're going to multiply that by 100%. Okay, or if we have a sample, do the same thing, take the sample standard deviation divided by the sample mean and multiply it by 100. So to figure out which of these two I'm going to use, sample or population, we need to read in our problem. So let me make a little chart here. I have data set A and data set B. I need the standard deviation, and I need to read carefully to figure out whether that is sample or population. I need the mean, and then I can use these two to calculate the CV. So I'm going to go back to my problem over here. Here, see where it says sample data? So that's going to tell me that I want to use the sample standard deviation as opposed to the population. And again, down here it says a set of sample data. So to find the sample standard deviation, I hit equals to enter a formula, and then STDEV dot. And then we're going to choose the S for sample. Open the parentheses. Then I'm going to select my data, close the parentheses, and hit enter. Similarly here, I'm going to hit the equal sign, STDEV dot S for sample, open the parentheses, and find the standard deviation of my second set. And then for mean, the formula is the same. It doesn't matter whether you have a population or a sample, equals average, and select my data, and then equal average and select my data. Now to find the coefficient of variation, equal sign again, then I want to take the standard deviation for A, divide it by the mean for A, and then multiply it by 100 to change that to a percent. Now for the second set, equals, choose the standard deviation over here, divided by the mean, and multiply that by 100 to change that to a percent. With these two coefficients of variation, we can compare this 10% versus 3.4%. These vary more. These are more spread out. Okay, do you see how you might not come to that same conclusion by looking at the standard deviation, because the magnitude of data set B is much bigger. These numbers are larger. So I wanted to take a second and show you how to do example 3.14 using Excel. Okay, next on mine, using the empirical rule, and I'm given two values. This is like 3.16a. I'm going to take each of these values, subtract off the mean, then divide by the standard deviation. Take this value, subtract off the mean, divide by the standard deviation. If I have 1 and -1, then that's going to be 68%. If I have 2 and -2, that's going to be 95. And then if I have 3 and negative 3, that's going to be 99.7. So these are straightforward, just like 3.168. Chevy Chevs here, I know I'm going to use Chevy Chevs, but this does not give me a value like the example in the book. It gives me a percentage. So I need to help you guys with this one. Okay, in the example in the text, we were given two values and had to find the percentage. Well, this one's a little different. Here, I am given a percentage, and I need to find those two values. Okay, so I need to figure out whether this is 2, 3, 4, 5, how many standard deviations for the mean. Our formula here, we have 1 minus 1 over k gives us the percentage. Well, what we don't know right now is what is this k. Okay, so if you were to, for example, plug in 2 and go 2 standard deviations, that would be 1 minus 1 over 2 squared, which is 1 minus a fourth, which is 75%. Well, that's not what we're looking for. We were given 88.9%. Okay, again, if you go on to the next one, we say if we go 3 standard deviations, we have 1 minus 1 over 3 squared, which is 88.9%. Well, yes, this is what we're looking for. So we know that for our example, k is 3. Again, we could go on if k was 4, right? We would have 1 minus 1 over 4 squared, which would give us 15 over 16, which is 93.75%. We figured out then that our k is 3. So for us, our percentage for Chevy Chevs is 88.9%. So that told us that k is 3. Okay, so what I want to do is I want to start at the mean, and I'm going to subtract 3 standard deviations because k was 3, and then I'm going to add 3 standard deviations. So if I start at 7.2, and I subtract 0.4, 1, 2, 3 times, I would get 6.0. That would be my lower limit. If I start at the mean, which is 7.2, and now I'm going to add the standard deviation 3 times, because k is 3, then I would get. So I wanted to give a little more instruction on this one because there's not an example like this in the text. In the example in the text, they give us the values and ask us to find the percentage. But it's the same idea. So next, I have an empirical rule problem, and I am just given one value as opposed to 2. So this is like 316b. What we're going to do is take the value, subtract off the mean, and then divide by the standard deviation and find the area either to the left or the right. Now, rather than do all of this over again for you, what I want to do here is just pause and show you how to find those percentages for -3, -2, -1, 0, 1, 2, and 3. And then once you find their z-score and figure out if you're from the right or the left, it's going to be just like the one I worked for you previously. That's 3.16b. Okay, so the values that we were given were between -1 and 1 is 68, -2 and 2 is 95, and -3 and 3 is 99.7. What's a little tougher is when we just have one value and we want to find the area to the left and to the right. So I'm going to help you with that now. So let's start with -3. So let's say I was down here at -3. Okay. Well, if we were between -3 and 3, we know that would be 99.7. So there is 0.3% missing. So in this bottom tail right here, if I take that 0.3 and chop it in half, that would be 0.15% down here. And then I'm going to have 0.15% up here. Okay, so to the left of -3 would be 0.15%. And then to the right is going to be that 99.7% plus the 0.15%, which would give me 99.85%. So now let's see if we can do that for negative 2. So if I was at negative 2, in between negative 2 and 2 we have 95%. So I'm missing 5%. Well, that 5% that I'm missing is divided among these two tails. So because this is symmetric, this is going to be 2.5%. And up here is going to be 2.5%. Okay, so to the left of negative 2, we're going to have 2.5%. And then to the right, I have this 95% and then 2.5% more. So that would be 97.5%. Because remember, all this always has to add up to 100%. Next, I think this is the example that is given to us in the text. If we were at 1 or negative 1, well, we have 68% here, which means we're missing 32%. So if I divide that among the two tails, well, that means I'm going to have 16% here and 16% down here. So to the left here, we're going to have 16%. And then to the right here, we're going to have 68 plus 16, which is 84%. Now the easy one, 0 should be half and half, right? So if this was right in the middle, it'd be 50% and 50%. So let's move on to 3. So if I'm at 3, positive 3, well, to the right, we have that 0.15%, right? Because this is symmetric. And to the left, we have the 99.85. For positive 2, to the right, we're going to have that 2.5%. And then to the left, we're going to have 97.5%. And then lastly, again, this is the case done in example 316b. If we're at 1 here, I'm going to have 16% above and 84% below. All right, so those are the cases we have. So if I go here to my problem, I take the value, which is 116. I subtract off the mean of 99 and I get 17. I take that 17 and divide it by the standard deviation, which is 17, and I get positive 1. Okay, so I read my problem here and it says at least 116. Okay, at least 116. So that would be anything 116 and above. So I want the area to the right of positive 1. So positive 1's over here. The area to the right for at least would be 16%. Here is another one. If I take 88, which is my value, and I subtract 101, I get negative 13. If I take negative 13 and divide by 13, I get negative 1. Now, what we want here is less than. All right, so less than would be the area to the left. So if I come back to what we just did, the area to the left of negative 1, that's this case right here, which is 16. Here in this example, I'm using Chevy Chevs, and I'm given two values. This is exactly like 317, example 317. I take the value minus the mean and then divide by the standard deviation. And I'm going to do the same thing with the lower value. And if I get 2, I can plug it into that formula and get 75%. If I get 3, I can plug it into that formula and get 88.9% and so forth. So this one, I'm doing Chevy Chevs and I'm given two values. This is just like 317. Okay, here's another empirical rule with one value. This is our hard case like we've just been practicing. If I take $3.89, subtract off the mean, and divide by the standard deviation. Now that one I can't do in my head. I take the value of $3.89, I subtract off the mean of $8.36, and then I'm going to divide that by the standard deviation of 1.49, and we get -3. So we're -3 standard deviations. We're 3 standard deviations to the left. So what we want is no more than that. So not more, that's going to be the area to the left. So if I come back here, the area to the left of -3 is 0.15. So this would be 0.15%. Okay, so I hope those hints will help you with section 3.2b.